on your test, Mike, I've got at least 2, I think 3 or 4, I've forgotten because I was typing it a while ago, collisions like this. So if there's a collision or an explosion, it's a job for conservation of momentum. Let's do my favorite student. And Sirki, just to mess with you, I'll spell it different yet again. A hockey player, you know what? I see a compass rose. In Physics 12, I often, as soon as I see north, south, east, or west, as a habit. Find it yet? Okay, keep looking. As soon as I see that as a habit, I'll draw a compass rose. Why? Once again, Tristan, I've written something down. I feel that you got the quiz? Okay. Again, if you didn't do it, foolish you, don't just copy out. Try this later on. Try this tonight. Try this tomorrow night as part of your study. I do a compass rose. So a hockey player is moving north, collides with another player who's moving south. Dylan, do you see north in this question? Say yes. Tristan, do you see south in this question? Say yes. There's a change in direction. Momentum is a vector. Tristan, which way do you want to be positive, north or south? I don't care. Pick. Okay, so I'm going to go a positive above the word north, a plus sign right there, a minus above the word south, a minus right there. And this 1.3 is negative because it does say 1.3 south, and you said south was negative. Okay. Before the collision, this is a job for conservation of momentum. If you wrote that down, that will get you some marks. Before the collision, who's moving? You know what? I'm lazy, Emma. I'll put a letter A above the 72, and I'll put a big letter B by the 65, and I'll use mass A and mass B. Find it? Yeah. Woohoo! So before the collision, what's moving? Mass A, mass B, both or neither? I think both, and I think separate, because one's going north and one's going south. This would be like 2 hockey players taking a run at each other. So I'm going to have M1 V1 initial plus M, instead of 1, I called it A and B, sorry. M A V A initial, M B V B initial. Why do I put a vector sign above the V but not above the M? V is a vector. It'd be wonderful. It was an easy way to remember that velocity is a vector. I got nothing. M is a scalar, so I'm just being careful. Wham! They collide. After the collision, you good, Chloe? You awake? Yeah? Okay. Stuck together or separate? I think both are moving, and I think separate. Now, what's my reasoning for separate? Well, it wants the final velocity of the second player. It gave me the final velocity of the first player. If they were stuck together, they've given me the answer, because it would also be negative 1.3, so that's a little silly. So I'm going to go M A V A final plus M B V B final. And it looks like this is what they want me to find. I think to do that, the MAVA initial plus MBVB initial, the right-hand side just drops down like a domino. I think Christian moved that over by minusing it, yes? And I think I will divide by the mass of B. That's going to give me the final velocity, and now it's plug and chug. Careful, plug and chug. I got 72. I got 7.5 plus. I got 65 negative 8.1 minus 72 negative 1.3 all over 65. Running out of room here. Is this a fraction? Yes. Brackets around the top. I don't think I need brackets around the bottom. 72 times 7.5 plus 65 times negative 8.1 minus 72 times negative 1.3. Close off the top, divided by 65. What's the positive telling me for a direction? North. So I guess if north is up and south is down, I guess they ran into each other, and the top guy that was moving south bounced backwards moving north. If I do this sideways, it would be like bouncing off each other in a head-on collision. That physically seems possible to me. I'm okay with that. So V final is 1.65 meters per second. And I usually put an at symbol, especially if I don't write the word north. If I just do that, an N after an at symbol is north. Otherwise, I think it's newtons, and that's too confusing. If you got that, 3 out of 3. Otherwise, 1, 2, 3, 4. Yeah, I would probably do something like this. 1 mark if you recognize that it was conservation momentum. I would give you a half mark for that. A half mark for that. You know what? I would give you a half mark for recognizing that it's conservation momentum. I take that back. Half mark for that. So far I've used up 2. And then usually what I do is a half mark for the magnitude and a half mark for the direction. But as always, if you showed some work and you got the right answer, Emma, 3 out of 3. I'm trying to show you all the steps. This is an example of a head-on collision where they bounce apart. I bet you all also have an example on your test of a head-on collision where maybe they stick together. By the way, when they bounce apart, elastic or inelastic? Elastic, rubber band, bounce apart. Elastic. Yeah. Number 2, now they want me to find an impulse. Okay. Well, I know that impulse is change in momentum. Also, you'll notice in question number 2, May, we're only looking at one mass. That's another hint that we're going to find this with impulse. I do notice 2 different velocities, which suggests to me that I'm going to go mv final minus mv initial. The mass, 0.052. Is there a change in direction in this question? Yeah, then I'd better let one way be positive and one way be negative. Mike, I think I would let up be positive and I would let down be negative because that makes more sense to my brain. So final is going to be positive 6.2 minus, because impulse is change in momentum and change in anything is final, minus initial. It's going to be 0.052 times negative 8.2. 0.052 times 6.2 minus 0.052 times negative 8.2. This would make a nice multiple choice question, and I guarantee one of the answers I wouldn't have the negative there. I'll bet you one of the answers I'd forget to change the 52 grams to kilograms, because I don't know what happens. Do you get 0.7488? No, am I wrong or right? Not, yep. So, magnitude and direction, 0.7488, and that is kilogram meters per second. Direction. Gotta be, because I said up was. Are you positive? Shut up. So I would go half mark for that, half mark for that, half mark for the equation, and a half mark if you said that it was MV final minus MV initial. But again, Sierra, if you got the right answer, 2 out of 2. Sierra, what's B asking me to find? There is enough that you could go F equals MA. M is 52 grams, 0.052. And you could find A, I think, by going VF minus V over. And if you did it that way, I'll give you full marks. Since I found impulse in part A, I have a shortcut. I can say that force is impulse over time. It's going to be 0.7488 over 0.15. 0.7488 divided by 0.15. I get a force of 4.992. Direction. Did I get a positive answer? Up. Half mark. Half mark. Half mark. Half mark, but if you got the right answer, 2 out of 2. Turn the page. Very good. Number 3 wants me to find average force. Chloe, you absolutely could go F equals MA, and you could find A, and you totally works. I'm going to do this with the impulse equation all in one step, because the impulse equation says force equals impulse over time, except instead of writing impulse there, Emma, I'm going to write mv final minus mv initial, because that was another way to calculate impulse. And I've already got the F by itself. So it's going to be 1200 V final. I did a quick check. There's no changes in direction, so I don't need to let one of these be positive and one of these be negative. Minus 1200 times 12, all divided by 8. Do you get 1950? Okay. And again, if you got that 2 out of 2, if you went F equals MA and found A, absolutely 2 out of 2. Otherwise, oh, by the way, they just said magnitude. Why didn't they say magnitude and direction? Because the question didn't give me any directions. Could be going east, could be going west, could be going north. I don't know. So I would probably go half mark, and I guess 1 mark for the answer since there's no direction. Change in velocity. Well, impulse, which is force times time, is also equal to impulse. Now we're putting that equation together in all of its formats. Brian, how would I get the delta V, the change in velocity by itself? So you're telling me that the change in velocity is going to be force times time divided by m? You would be correct, sir. It's going to be the force, 120. The time, 8, divided by 40. I think I can do this in my head because it's going to be 240 divided by 24? Yeah? Meters per second. Half mark, half mark, half mark. What does that mean, Brian? It means if I started out at 0, I'm now going 24 meters per second. If I started out at 5 meters per second, what's my final velocity? If I started out at 5 and my change in velocity was 24, 29. That make right? Started out 5, my change in velocity is 24. Now I'm doing 29. If I started out at 10 meters per second, what's my final velocity? Yep. The change in velocity just tells you what it's increased by in this case. Increased because it's positive. Last one, collision. This is a job for conservation of momentum. I see directions. I'm going to call George mass A, and I'm going to call East positive. I'll call Jim mass B. The other thing I could do is I could use G for George and J for Jim, and that would probably be clever as well. West, negative and negative. And after the collision, east is positive. Here we go. The sum of all the momentum before the collision equals the sum of all the momentum after the collision. Before the collision, what's moving? George, Jim, both or neither? Both separate. So I'm going to have mass A, velocity A initial, plus mass B, velocity B initial. Wham! They collide. After the collision, both, and I think separate, mass A, velocity B, Mr. Duick, A final plus mass B, velocity B final. And it looks like, in fact, I think this question is pretty much identical to question 1. It's a different topic, but I think it's the same physics here. We want Jim, right? That's mass B? Yeah. Okay. So we're going to get, I think, the same equation. The mass of A, VA initial, is going to drop down like a domino. The mass of B, VB initial, is going to drop down like a domino. Then there's going to be a minus mass of A, VA final. and that's all going to be divided by the mass of B. That's the velocity of B final. It's going to be 65. I notice I didn't do anything here that stick together. There is going to be one on your test where the objects stick together. So make sure you're okay with that. 12 plus 85 negative 4 minus, George, 65 east positive 4, all divided by 85. It looks like in this collision here, Jim kept going forwards after the collision. Sorry, George kept going forwards. I think this one, Jim lost the collision. He's going to get knocked backwards. I think he's also going to have an east velocity. Let's see. 65 times 12 plus 85 times negative 4 minus 65 times positive 4. Close off the top, divided by 85. Do you get 2.11, or have I done something wonky? Is that right? No? Am I wrong? Am I wrong? So you got? Okay, I didn't see any nods. Positive direction would be east. So can I fit this in here? V final is 2.11. Did I round off properly? No, 2.12, Mr. Duick. Meters per second at east. Half mark. Half mark. Half mark. Half mark. Half mark. Half mark. Can you give yourself a lovely score on this quiz out of 14, please?